Good morning, dear students. We are discussing regarding this environmental engineering one subject. In that, we have discussed the content or the topics like the protected water supply system, objectives, and what are all the suspectable diseases if the water is not supplied in a good potable mode. We have discussed all the possible diseases that may spread because of the contaminated water we discussed. After that, we discuss water demand and what are the factors affecting water demand we have discussed. And after that, we also seen in the previous class like the components like size of city, cost of the water, climatic conditions, industries, living standards, in the name of factors influencing water demand. And here, after that, we already seen the fluctuations which may occur, which may be observed because while the water is being supplied, also we observed with respect to hours and with respect to seasons. We have discussed per capita demand. How can we find out this per capita demand? We have discussed. And now we are in the topic design period. Here, design period in the sense the pipe materials, the structure, whatever we are selecting, that must be competent enough, that must be fit enough to meet the requirements of the purpose. While it is being meet the need of the people, need of the purpose, the design period must be calculated, the design period must be observed in such a way the purpose of the people can be fulfilled. See here, what we discussed is in the name of design period, it can be defined as the number of years in future up to what the proposed structure will be available to meet the requirement. We can conclude it as period, design period, the number of years in future. We already discussed about this definition in the past class, in the previous class. Now we are here, the factors affecting design period. What are the different factors must be, what are the different factors supposed to be considered while the design period is being calculated? In that, the first component is life expectancy. The life expectancy of materials what we have chosen must be high than the design period. Then only we can fulfill the purpose of the need. After life expectancy, see here, we have seen the life expectancy of different materials that will be used in water supply system, steel pipes, concrete pipes, cast iron pipes, where the steel pipes life expectancy is 25 to 30 years, concrete pipes 75 years, cast iron pipes 100 years. So next one is the lead time. Lead time. You may be here exam time, you may be here class time. Now it is the lead time. What is this lead time? Yeah, nothing is there here. This is, as it is written, this is the total period of time of any project from the perception to starting of the project. From the perception, from the thought to reality. How much time it has taken, the lead time, is the total period of time of any project from the perception to the starting of project. Normally, the lead time must be minimum. See, for suppose you are going to start one particular project from one particular day you thought, and you are initiated perception, you are initiated with all your readiness. In that readiness, economy is the one of the component. You're ready with the budget for starting off the project. If take much time, or if take more time, you may lose the interest of the money. That means once the perception has started, that should come to the world of reality, then you can yield the benefit of the project. That means the lead time means here the time from the perception to the starting of project. It's called as the lead time. The lead time here I mentioned here, normally whenever the budget has allocated from the banks, the lead time must be minimum to avoid the charges of interest rates. You have taken the loan with your perception, and if you are getting late or if you are delaying for some reason, banks won't stop you asking interest. That means what I'm speaking is here, from the perception to starting of the project, the time period must be minimum so that we can skip the interest changes. Lead time, the time from the perception to the starting of project, is called as lead time. Next one is economy. The design period, you started one constructing one overhead tank. For some reasons, if you are unable to complete the what, under some reason, in the sense, if it is the economy, it may be loss. See here, it may be loss with respect to economy only. It is one of the major parameter. See here, because the money has taken from interest from the project, taken for interest, the project must be finished within the stipulated timings. If not, the existence of project may not meet the requirements as per the design period. That means proper amount of budget has to be allocated to complete the project within the period. That means if you have if the structure has a design period of 20 years, because of economical reasons, if you finish, if you are unable to time within the stipulated timing, if it has taken 5 years to complete the project, which has the 20 years of design period, it may not meet the real requirements of design period, because for establishing the structure, 1/4 of the years are spent. See here, next one is population. The other parameters to be considered in design period is the population is highly considered factor at the time of designing water supply system. Normally, the population of 2 to 3 decades will be considered. There are different methods to forecast the population. See here, the population also one of the parameters to be considered in the design period. If it is the water supply system, you must consider the population of upcoming 2 decades, then only the purpose will be fulfilled. Expansion feasibility. The structure must hold the feasibility of expanding in future. That's why we used to hear at certain companies, at certain industries, unit 1, unit 2, some unit 3 like that. That is plant 1, plant 2, plant 3 like that. That means that has that it must has the expansion feasibility. See, next one, the topic is estimation of water demand. See here, that means you understood the topic, I think, design period and factors influencing design period. The first one is life expectancy, lead time, economy, population, expansion feasibility, all comes under the umbrella of influencing factors for design period. Next one is estimation of water demand. How can you estimate this water demand? So far you heard how much water that should be given to one particular human being as per the norms. 135 liters per day is the minimum requirement per one per capita. See here, there are two considerations while estimating the water demand of any area. Normally the following specifications will be considered. The maximum hourly consumption is usually taken as 180% of average consumption. The maximum hourly consumption usually taken 180% of average consumption. At one particular period of hours, the consumption is normally 180% to the average consumption. That means in that particular hour, the consumption is 180% to the average consumption. Therefore, hourly consumption of a maximum day can be calculated with respect to 1.5 into maximum hourly consumption, 1.5 into maximum daily demand by 24. Hourly consumption, how it comes by 24. That means here maximum daily demand by 24. How can we get the maximum hourly consumption? How can we get maximum hourly consumption? Simply by 24. How many hours? 24 hours. That means maximum daily demand, maximum hourly consumption, when we can get it? By taking the maximum daily demand by 24, because 24 hours. To that, 1.8 into average daily by 24. Why 1.8? 180% of average consumption. 1.8 into average daily demand by 24. So 1.5 into 1.8 into Q by 24. See here one more time. See here 1.5 into, this is the empirical, 1.5 into maximum hourly consumption. How can we get the maximum hourly consumption? Simply by 24 only. See here, what is the maximum hourly consumption here? To 180%. 180%. So 1.5 into 1.8 by 24. 1.5 into 1.8 by 24 equal to 2.7. That means 2.7 into annual average hourly consumption will give the water demand of that particular area for that particular point of time. One more time. See here, what we are speaking, what he is here is the word is speaking, the maximum hourly consumption is usually taken as 180% of average consumption. How can we get this maximum hourly consumption? Simply, see what is this 1.5? It is the empirical 1.5 into maximum hourly consumption. How can I get maximum hourly consumption? Simply by going with the by 24 hours. In that 24 hours, 1.5 into why put it this 1.8? Because it is clearly mentioning that 180% of average consumption to find out the maximum hourly consumption. What is our maximum hourly consumption? So 1.5 into 1.8, the average daily by 24. So 1.5 into 1.8 into Q by 24. This is the formula. This is the empirical formula where we get the answer 2.7 to estimate the water demand simply by adopting 2.7 into annual average hourly consumption gives the water demand of that particular area to that particular point of time. Next one is population forecasting. Here, population forecasting is one of the mandatory component one has to learn once you are appointed as an environmental engineer, where you are going to calculate water demand of one particular area, where you are going to construct one particular overhead tank. You must be considered minimum. You must be known how to calculate population. See here, one of the parameter population is here. 2 to 3 decades will be considered. Normally, if you go for water supply system, new water supply system, the upcoming 2 to 3 decades of population has to be considered. So how can you calculate? Simply, there are different methods to find out the population. In that, the first one is arithmetic. There are different methods. We are going to discuss here 4 or 5 methods. First one is arithmetic increase method. Next one is geometrical increase method, incremental increase method, comparative graphical method. See, arithmetic increase method. Normally, this method is formula by using, see here, by adopting the formula Pn equal to P plus NC, P present population, number of decades, average constant. Here, I just taken an example from the textbook. If it is the classroom, we'll go for a practice and I'll call you randomly and we'll go for number of problems. Here, this is then based on this online session. This is on the demand. I just taken one particular example from textbook, and we are going to discuss how can we calculate the population by using this arithmetic increase method. See here, year 1940, the population was 8,000. 1950, the population was 12,000. In the 1960, 17,000. Whereas in the 1970, 22,500. Find the probable population in the year 1890 and 2000. How can we calculate? See here, 1890 and 2000. See, we go for table 40, 50, 60, 70 and the population. See how we got, see from 1940 to 1950, we observed 4,000 increase. The number of population is 4,000 increase. And by from 12,000 to 17,000, here is 5,000 increment. From 1960 to 1970, here is 5,500 increment. By summing, simply we got the answer 14,500. 14,500 by 3 average, we got the 4,833. Take a paper and pen, go for it. 14,500 by 3, where we get the answer 4,833. Take a calc and find out. You please take the calcs and go for it. And after that, what is the solution here? What is the problem? Equation is Pn equal to P plus NC. N means number of decades. See, for what decades we need to find out? 1980, 90, and 2000. Right? 1980. The population was, see, for 19 to find out the population of 1980. The P means present population. See, where we have the population of 1970 only. That is the present population when we are going for 1980. So present population is 22,500, and formula is P plus NC. See here, P plus N into, see here, N into C. P plus 1 decade. 1 plus 4,833. 1 decade. N means 1 decade. P plus present population plus N means 1 decade. 4,833. You'll get the answer 27,333. See, by 1990 to the population 2 decades, 22,500. The present population plus 2 into N is equal to number of decades. 4,833, 32,166, 22,500 by 2,000. For 2000, the present population was still 22,500 plus N into C. 3 into 4,833. That means 36,999. This is what about the arithmetic increase method. Simply we are adapting this formula P plus N into C. See here, P present population, N number of decades, C average constant. This is the average constant. Understand? P plus NC. Problem. P plus NC. P plus NC. 1 decade, 2 decades, 3 decades. This is the way to calculate the population by adopting the method arithmetic increase method. Next one is geometrical increase method. This method is based on the assumption that the percentage increase in population from decade to decade remain constant. In this method, the average percentage of growth for last 2 decades is determined, for last few decades is determined. The population forecast done is then basis that percentage increase per decade will be the C. And the formula is Pn equal to P into 1 plus Ig by 100 power n. We'll see how we'll calculate as per this formula. See here to the same problem, here up to here, 4833 average constant. Now, one more column added here where we are finding out 51 population percentage. See here, increment is 4000 from 1950 to 40, 50 12,000, and 1940 the population was 8,000. The increment is 4,000, and 4,000 by 8,000 into 100. We are finding out the increment of the population in percentage, 50%, and here 5,000 by 12,000 into 100, and here 5,500 by 17,000 into 100, where we get the percentage 30.4, and average constant 124 point. So all 50, 41, 32.4 it sums up. Take the cals and do it. 124.1% by 3, 41.37 percentage. This is percentage increase. Now the formula is, what is formula? P into 1 plus Ig by 100. What is this Ig? This is Ig, percentage. See here, formula 1 plus. That means here 1 plus in the sense P in present population plus Ig 41.37 by 100 power n, present population 31,808. Understand? Present population. Again, 31,808 plus 41.37 by 100 into 31,800 equal 49,935, and plus again 41.37, and hope you understood. We get the answer 68,524. Simply, we are just taking this formula 1 plus Ig by 100 power n. Understand? Simply this formula we are adopting. Again, this particular column only new to this geometrical increase, because Ig, the term Ig is the percentage of the population that is increased. This is Ig, percentage increase in population. How we got this Ig? Simply by calculating its percentage of increase. 4,000 is the increment when compared to the 50 to 40. So 4,000 by 8,000 into 100, 50%. Likewise, we got 41.37, 80, 90, 20, and this is the answer we got. Very simple, very simple. Go with cals and do it accordingly. Easily you can get it. This is about geometrical increase percentage method. And next one is incremental increase method. This method improvement over the above two methods. The average increase in the population is determined by the arithmetical method, and to this is added the average of the net incremental increase once for each future decade. Simply simple, nothing is there here. What I read, this is the formula. This is the formula, and up to here, and here one more column that is added. In here, this was added, and now it is adding. I see incremental increase. Up to here, how much of increase. See here, 12,000. See 4,000 to 5,000. How much increase? 1,000. Because here no increase, because we don't know the value. The increment is 4,000, and up to 4,000 to 5,000 to the difference 1,000 plus 1,000. And I see after 5,000, see here the population was 5,500. That means here 1,500 population was increased, and Here the total is 2500, average is 1250, incremental increase average. That's not, I said that net incremental increase, average of the net incremental increase, added the average of the net incremental increase. See, go for it. The formula is P plus N into IA plus IC. P plus present population 22,500 plus N IA plus IC. N in the sense 1 decade, 2 decade, 3 decades. IA means 4,833 plus 1250 into 1 decade into N. N in the sense number of decades 1. This is the answer. And we go for present population even for 1990. The present population is 22,500 plus P plus N into, see here N, number of decades, IA plus IC, IA plus IC. See here 4,833 plus 1250, 28,583. Likewise, we'll get the population for the future decades of 90, 80, 90, 2000. And other methods also there. The methods we'll discuss next class. Today we have discussed about the population forecasting. In that, we have discussed arithmetical increase method, geometrical increase method, incremental increase method, and the rest of the methods we'll discuss in the next class. See here, today we discussed about the factors affecting design period. Factors affecting design period in the sense, see here, what are all the different factors we discussed? Life expectancy of the materials that is being used to the proposed structure of the proposed structure which has the design period, and by what, by depends on what the life expectancy will be considered for the materials that is being used to the structure. Did you understand what I said? Nothing there. Life expectancy of material that is being utilized, which is inbuilt component of design period of any proposed structure or any proposed system. That is why life expectancy they have given the priority as one of the component of influencing design period, followed by lead time, economy, population, expansion, feasibility. And this is the formula. Here you must remember thumb rule. The maximum oil consumption is usually taken as 1.8 to the average consumption, average daily consumption. How can we get? Simply by 24. So 1.5 into 1.8 into Q. This is formula. How we get it? This is empirical formula. See, you must remember 1.5 into 1.8 into Q by 24 equal to, answer is, see, go for cals, go with cals 1.5 into 1.8 within the into Q by 24, where the answer 1.5 into 1.8 into Q by 24 equal to 2.7. To that 2.7 into annual average hourly consumption, we'll get the water demand of the particular area. Understand? And next one is population forecasting, where we are going to discuss about different methods. In that, today we have seen the methods like arithmetic increase method, geometrical increase method, incremental increase method, and the other methods we'll discuss in the next class. If any doubt, see, take a pen paper and go for these conversions. If you have any doubts, make a call and give me a message, and you can give the mail also. Even the formula here, population forecasting, nothing is there. Just go with cals and find out the values, how you got it. Please make a call if you have any doubt, so that your doubt will be clarified. Thank you.